Hello everybody, and today's lesson is on congruence and transformation. So in the pictures that you see here, we have all different kinds of transformations that occur. Different types of architecture uses patterns and translations, rotations, reflections. So if you can see here, this right here, this shape has been repeated over and over and over. It's just slid like copy paste, copy paste, copy paste. That would be translation. You're just sliding it from one place to the other. Same thing here with the windows. And then here we have a pagoda, and the little roofs here for each level basically, as you go up, get smaller and smaller and smaller, and that would be a type of dilation. Alright, so as you can see here, transformation, there are 4 different types of transformations we're going to talk about. We're going to talk about slides, which are translations, flips, which are reflections, turns, which are rotations, and dilations, which magnify or shrink, meaning make it bigger or smaller. Alright, so as you can see here from this table, there are different things, different types of operations that we need to do to our coordinate in order to translate, rotate, reflect it, whatever we're doing. So, in the translation, if I have a point x, y, so let's say 5, 4, and I want to move it up or down or left or right, I have to add to the x or y value. Adding a number to the x would move it in either the left or the right direction. So adding a positive number moves to the right, adding a negative number moves to the left. Now adding a number to my y value either moves it up or down. Positive up, negative down. Okay? So we move it A units horizontally and B units vertically. With a reflection, there are 2 different types of reflections. Whew, I can't talk today. If we have an x and a y, okay, we can either negate x or negate y. And what happens is when we negate x, it reflects over the y-axis. When we negate y, it flips over the x-axis. It's a reflection. Remember, like reflection, looking in a mirror, seeing your reflection. We did talk briefly about the reflection property, okay? And then rotation, there are actually 3 different types, okay? First off, in the first type, you're going to flip x and y and make your x negative. In the second, you flip x and y, but this time y is negative. And in the third, you keep x and y where it is, but you make them negative. Here's what this does. This right here rotates at 90 degrees clockwise. This one, the second one, rotates at 90 degrees counterclockwise. And then doing them both, making them both negative and not flipping them, makes it a 180 degrees turn. This is the same as doing a 90 degree turn clockwise and another 90 degree turn clockwise. And last but not least, we're going to talk about dilation, okay? If I have x and y, I'm going to multiply x and y by some letter k. If k is a fraction between 0 and 1, then what's going to happen is it's going to shrink. Now, if k is larger than 1, it's going to magnify. If k is negative, then you have to start looking into your reflections, because remember, when we make things negative, you know, things start to move across x and y axis or start to rotate. Alright, now congruent figures, this is very important, have the same size and shape. We know that if we have 2 rectangles, those rectangles have to be the same size. They're already the same shape, but they have to be the same size in order for them to be congruent. Now, congruent figures can only happen if I have a rigid motion. So let's say that I have this triangle down here. Rigid motion includes reflections, translations, and rotations. So if I want to translate it, move it to the right, that is still the same shape. If I want to rotate it, it's still the same shape. If I want to reflect it, so let's say flip it left, right, that is still the same shape. Now, dilations are not rigid motion. Here's why. If I were to dilate this, either making it bigger or making it smaller, do you see that this is not the same shape as the original? Okay, so what I'm going to do is I'm actually going to clone this. Okay, look, these 2 are congruent shapes. As soon as I dilate one, they're no longer congruent. In fact, they're actually called similar, but they're not congruent. Dilations, this is very important, dilations do not make congruent figures. Okay, isometry is a transformation that preserves length, angle measure, area, and produces an image that is original to the original. Basically, it just means that you're using rigid motion. Okay? Alright, so what we have here is we want to make a transformation. We are given that P, Q, and R are 1, 2, 4, 4, and 4, 2. And it's our job to plot those points. So 1, 2, 4, 4, and 4, 2. So what I've got here is probably going to be a triangle. Alright, so there's my triangle. Now we want to take and we want to add 2 to every x and add or subtract 5 from every y. So here's what we're going to do. Okay? If we have that P is 1, 2, we want to write that it's now 3, comma, and then 2 minus 5 will be negative 3. So that will be our new P prime. Alright, so if we were to add 2 to each x value and subtract 5 from each y value, these would be our new points. So now all we have to do is plot the new points. P prime is 3, negative 3. Oops. Q prime is 6, negative 1. Oops. So it kind of fell off the page there, didn't it? Alright, so here is my new triangle. This is just a translation of right 2 and down 5. And these two shapes are congruent because we used rigid motion. Alright, on number 2, this time we're going to take every x value and negate it. Notice the y stays the same. Alright, so now that we have our points, all we have to do is plot them. So I'm first going to plot ABC, which is 1, 1, 3, 2, and 3, 5. And we're going to connect those to make our triangle. Alright, now we want to plot A prime, B prime, and C prime. So negative 1, 1, negative 3, 2, and negative 3, 5, and connect those to make our triangle. Alright, so there are our two shapes. Notice that they are a reflection of each other. So you're going to write reflection across the y-axis. Because we did rigid motion, these are in fact congruent triangles. Alright, so let's move on to example number 3. Okay, this time we have 4 points, so we're going to have a quadrilateral of some shape. Let's go ahead and plot the points of the rectangle. Whoops, I gave it away. It's rectangle, obviously, R-E-C-T. So 1, 2 is here, 2, 1, 4, okay, 1, 4, 5, 4, 5, 2, and then back across. Alright, that is our rectangle. Now, what we want to do is switch x and y and negate y. So after switching x and y and negating our y term, these are our new points. So we want to go ahead and plot them, the first of them being at negative 2, 1, and then negative 4, 1, and then negative 4, 5, and negative 2, 5. Now, the question are these two rectangles congruent? Okay, before we answer that question though, the question is what kind of transformation is this? And this would actually be a rotation of 90 degrees counterclockwise. Alright? Now because it's a rotation is part of the rigid motion, so these are in fact congruent rectangles. Now some of you are saying, Ms. Norton, this does not look right. Okay, remember you can't TBL, you can't tell by looking, okay? You actually have to say, okay, this rectangle has a width of 2 and a length of 4. This one has a width of 2 and a length of 4. These are in fact congruent rectangles. It has to do with the way my grid is on my paper. So you can't just tell by looking, you actually have to see what type of transformation is occurring, and then based on that, is it rigid motion or not? Alright, on this one, I want you to give it a try. What we are doing here is multiplying every x value by 2 and every y value by 2. Alright, so I went ahead and found them being multiplying all my points by 2, and went ahead and plotted k, l, n. And now I need to plot k prime, l prime, n prime. So that's -2, 4, 4, 4, and 2, 6. Alright, so what we actually have here is a dilation. And because we multiplied by 2 to x and y, we have a scale factor of 2. Whatever we multiply is our scale factor. Are these two shapes congruent? The answer is no. Dilation is not a part of the rigid family. It's one of those, he doesn't even go here kind of jokes, right? The dilation is not a rigid motion, so the answer is no. We do not have congruent shapes here. Alright, now on occasion we will have two figures, and it's our job to map one figure to the other. So our question is can we map triangle ABC to RST by a reflection followed by a translation? So the first thing I would do is I would actually reflect ABC over the y-axis, okay? So once we've taken ABC and flipped it over the y-axis, we have a new shape. Now I can take this shape and actually drag it down 1, 2, 3, 4, 5. And this would overlap onto RST. So my next step is a translation, which means down 5. Okay? Now it says on triangle DEF and HJK can we map it from a reflection followed by a translation? Okay, well here's the thing. We can't actually reflect it. However, we can rotate it. So I want you to change this to rotation. The first thing you need to do is rotate triangle DEF 90 degrees counterclockwise. So what I would do to rotate 90 degrees counterclockwise, it's not quite so easy to see. So what I would do is I switch my x and y and negate the y. So D was 2, 1. So we switch those and it becomes 1, or -1, 2. Okay? Do that to all problems and you end up with this red triangle. Now, all I have to do is drag it up 1 and I will be equal to JKH. So all we have to do here is up 1. Alright. Now we have a couple of reflection questions. Explain how you would use tracing paper to help you find a sequence of rigid motions that maps one figure onto another. Now, tracing paper, think of the patty paper that we've been using. All we have to do is place the patty paper on top of the original shape and trace it. Then we can slide, flip, rotate the paper, however, until it matches. The only thing that we can't do here is we can't dilate with the patty paper or the tracing paper. Okay? You can't make it bigger or smaller. So we can use rigid motions, but we cannot use dilation. So it's another way to remember that dilations doesn't fit. Alright, when given two congruent figures, is there only one sequence of rigid motions that map one figure onto the other? Alright, really we could say no. If we go back to our previous figure, we could have moved up triangle DEF up one space and then rotated 90 degrees. Okay, so we could have switched the two. We could have translated then rotated, and it's no one set way. Okay, so for like when I give you problems and I say, you know, solve 1/5 parentheses a plus 10 equals -3. Remember on that homework assignment, you were able to do it a couple of different ways. Okay, and that's the same thing for transformations. Okay, well that's it for transformations, and I will talk to you guys later.